This is problem 2295, replace elements in an array. So the problem, let's start with the problem, then to the tactic, and finally the code implementation and time complexity analysis. So the problem, we are given zeroth index array nums that consists of n distinct positive integer. So remember this is a distinct positive integer. Nums, distinct positive integer. Now apply m operation to this array, where in the ith operation you replace the number operation I0 with operation I1. So we are giving a list of operation. Basically there are m numbers of operation, and for each ith operations what we need to do is we need to replace the number from the zeroth with the number from the index 1. So what it means is it replace, let's say this is the operation, we start from the first operation here. So we will replace the value 1 in nums with the value 3. So that's why in this explanation step you can see that we replace 1 with 3. Then the next operations is we are replacing the value 4 with 7. So that will be this one. And finally, we replace the value 6 with 1, which is this one. So you see. And finally, that's what we got after applying all the operations. Now we are asked to return the value of the array, the nums, after we apply the operations. So it is also guaranteed that in the ith operation, operation I0, this one, will always be exist in the nums. And it's also guaranteed that operation I1, this one, does not exist in the num. So what this means, these are actually the essence. So now let's talk about the tactics, because we already passed on reading the questions and also running an example. So more or less we know what is operation, what is nums, and what is the desired output in a very generic way. Now let's talk about the tactics, how to solve this in an efficient way. In order to make the solution efficient, we need to focus on what is unique in the problem. What is unique in the problem, first of all, is the fact that nums is consisting of distinct positive integers. So every number here are distinct, unique, nothing duplicated. Another unique thing about this problem is that the operations, this one is guaranteed to be in the nums, while this one guaranteed not to be in the nums. What it means that for each operation I, this only going to be applied in one member of nums. That's what it means. That's the other way to translate those three unique conditions in the problem. That every operations going to only be applied to one member of nums, and that makes it a core idea on how to make a fast solution, an efficient performance solution out of this problem. Let's take this example and try to explain what we can do about the fact that each operations only going to be applied to one member in the nums. Okay, what it means is we can make us ourselves quickly search which nums to be operated on by converting the nums itself into a map. Remember that this one will always have to be here, and any member in nums will always be distinct. It means if we convert nums into a map of value into its index, then we can quickly operate on it by matching the zeroth member in the operation into the value of the nums that we want to operate on, and then we copy the index, and now the new value that is applied to the index is number 3. So what it means, first of all, let's convert this into a map of value to index. So we reverse it. So this one is value 1. It's in index 0. Value 2, it's index 1. Value 4, it's index 2. And value 6 is index 3 of the array in the nums. Now once we have this, let's do the operation 1, 3. Doing operation 1, 3 once we convert nums into a map is as easy as 1 will be converted to 3. So we now know that 1 is in index 0. So now this index 0, because we operated this 1, 3, will actually have the value of 3. So using the nums map, it is represented with this. This is the entry when we replace 1 with 3. And because we replace the index value of 0 into 3, this is no longer true. Now we need to mark it into some number that's saying that there is nothing here. Nothing holding value 1 now once we operated this one. Because now the value 1 become value 3. Index 0 become value 3. There is nothing else. Index 0 is because we already replaced index 0 to number 3. Of course, 1 holding nothing now. Now, how do we mark this? We will use negative 1. Why we choose negative? Remember that all value in nums are distinct positive integers. Okay? So it is guaranteed that nums always to be distinct integers operations. Though the problem here, it doesn't say that the operation itself will always map into something that is positive integer. Okay. If we are too scared of using negative because there is nothing here guaranteeing us that operation will be always positive 2, the value in the operations array, let's use something completely different, which is just use none. Okay, so definitely whether it's the operation will be negative, who cares? We can easily differentiate that. Now let's continue. Just now we already operate on 1. Then let's operate on this operation. This operation means we're going to replace the value 4 into 7. We find value 4 having index 2. So once we operate this one, it means now value index 2 will have the value of 7. So value 7 now holds the index 2, while this one no longer true. We make it none. Finally, we do the last operations. Value 6 is replaced with value 1. Value 6, it was having the index 3. So now we will make the value 1 to point index 3 to have the value 1. In this format, it means this one now will be having index 3, while this one no longer true. Once all is done, we just need to convert the map back into array. Remember, this is value to index. So when we go through this one by one, it means when we have this value index 3, let's copy this one first. It means index 3 now will have the value of 1. 0, 1, 2, 3. So this will have the value of 1. Index 1 will have the value of 2. 0, 1. When do value 2. So it stay. Index 0 will have the value 3. This one, value 3. This one, no index, no index. Index 2 will have the value 7. 0, 1, 2. Value 7. See, we got the value. So let me summarize the tactic. The tactic is leveraging the fact that nums are distinct and operation is guaranteed for the zeroed one to have been here and this one to not have been here, which in summary, in aggregate, that means that its operation will only be applicable to one number at a time. And when we know that, it means we can make us quickly know which number to be operated by converting nums into a map of value to index. So we invert the position. Once we convert into this format, operating on it is as easy as searching the key and then replacing it. Once we all done that, remember during that operation, we need a new entry value called none to indicate that nothing, no index pointing for that value that we put as a key. Once all is done, we just need to convert it back into a list. Now that's the tactic. Let's start with implementing the code in Python. Let's start first. So we will invert nums into a map. That will be the first order of things we will do. So for I, how to write in Python? Oh yeah, for I in range 0 to learn nums, we will make nums map having the value and pointing to the index. The value become the key, the index become the value. Once it's all done, let's do the operation. So for ops in operation, what we need to do, operation in operation, let's just do ops. We will make, remember that we need to make the value which is ops1 pointing to the index. We got the index by having what was in the zero. So remember, we got the index by accessing the zeroed value in the nums map. Remember this one? What? I already converted. So the original was this, right? That value 1 was index 0. So we got the value, the index for the new number 3 is by accessing nums map with operation 0. Then we got the index. That's what this is. Or if we want to make it clear, that's the index. After we got the index, now the index will be pointing to the new value, which is the ops1. Okay, so new value will be the ops1. That's what it is. That's what this operation is. And not to forget the older value, which is using the op 0 will become none now. Okay, so I will, after explaining it, I will just put directly there so we can save some lines of code. That's basically what we do for its operations. Now once it's all done, what we need is for value comma index in nums map dot items, I think items, we will make nums if index is not none, then nums index will have the final value, and finally we return back the nums. Let's test this out. Oh, this was my previous run. Answer, expected answer, it's correct. Let's submit this. Accept it. Yay. Means it's performant enough. Finally, let's go for the time complexity. This map creation is just big O(n), because as you can see, it's just going through one by one the numbers. This operation big O(m), number of operation, and then this one value index in nums map. Nums map is of course as many as big O(n). This is just if else and assignment, nothing there. So out of this it means the time complexity is the max between n and m. Yeah, it doesn't say numbers. Basically, this is the time complexity, which more or less we can say to be linear. So we have solved this problem with linear. Now, what to make it more clear why this is efficient, just imagine if you don't leverage the fact that these are this thing and then these are always be there while this one never be there during the operation. If you don't use that information, the brute force way to do this is actually when you uh, take the operation and operate it one by one from 0 to the rest. It means the time complexity will be m times n because there are m operations, and for each operation you have to go through each of the nums. So that will be m times n. So from big O(n) squared we make it into big O(n). That's why this is very performant by leveraging that simple fact. Okay, thank you for watching. Hopefully this is a fun and enlightening way of seeing the problem. Bye.